Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 536. In this episode, Scott talks with Richard Astbury about the Orleans Distributed Virtual Actor Model.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today, I'm talking with Richard Astbury, and he is a worker on the Orleans framework. You called yourself kind of an evangelist of the Orleans Virtual Actor Framework for .NET.
That's right. I'd really like to be more of a contributor, but I don't have huge amounts of spare time. So I try to talk about Orleans whenever I can, and I run the kind of Orleans Contrib organization on GitHub as well to try and encourage more open source projects around the Orleans space.
But you don't work for Microsoft.
No, I don't. No, I work for a little company in the backwaters of East Anglia in England.
But your focus is on cloud computing, and in the context of your consultancy, at some point you discovered Orleans?
Yeah, before Orleans was launched, a Microsoft friend of mine kind of showed me this thing on his computer and said, "Oh, you'd be really interested in this. It's really cool. It solves some really hard problems in distributed computing. It's right up your street." And so I got involved and kind of had access before it was publicly released, and then as Orleans kind of came out, I was quite involved in trying to help a community grow around it.
So sometimes we're doing our thing and we're focusing on a technology, and then another technology comes along and it lights up something in our brains, and it goes, "Oh, this is the one I've been waiting for. This is the framework. This is the language. This is the pattern." This is that pattern for you?
Yeah, I think so. I think this is the first C# kind of .NET project which tried to solve some of the hard things in distributed computing and make distributed computing accessible to the masses without you having to go and do a PhD in some obscure computer science stuff. You could just write C# as you normally do, and it just runs across a cluster of machines, which seemed really appealing to me.
Now, I'm oldish.
I don't think I'm far behind you, to be honest.
Yeah, but, I'm 43, and it feels like every 10 or 15 years there comes along a framework that promises to make stuff easy, and I was there doing COM and DCOM, and before that I was doing RMI and Java, and there were all these different frameworks that would promise me easy distributed computing. And it was always a lie, right? It never really worked out. The abstraction leaked. Is this one also a lie, or do we finally get it right?
Well, I think you're right. Nothing is new in computer science, and Orleans is an implementation of the actor model, which was pioneered in the 1970s by Carl Hewitt. Really for a different set of problems. He was trying to solve artificial intelligence problems and thinking about neural networks, and he was inspired by particle physics to design this actor model. And Erlang popularized this in the 80s with their system, and Microsoft approached the actor model in Microsoft Research. They have an extreme computing group who look at building hard stuff for fun, I think, and they decided to take a new look at the actor model, and rather than go down the Erlang implementation route of having supervision trees, they went down a kind of new thing, which they then coined the virtual actor model, where you have these actors that may or may not exist in memory. And then when you ask for them, they're created. And then sometime after you're finished with them, they're removed from memory. So the Orleans runtime takes away the burden of having to supervise lots of these little objects in memory.
So can I ask a couple of ignorant questions that have popped up in my head?
Go ahead.
When we say virtual actor model, and you're saying it's virtual and it may or may not exist, that makes me think about like pointers versus handles. And it also makes me think about dependency injection and the idea that there's a service out there and it has scope and it'll be waiting for me when I need it. And I just ask for it and I may get a new one, or I may get one that came out of a pool and I don't really care. Are all of those things underneath this?
Yeah, that's the kind of concept, I think. The framework takes away from you some of the problems you have in distributed computing, which are given a set of machines, which one has got my actor on it? And if I want to go and create a new actor, which machine shall I put it on? And I don't want to have it on more than one machine, because then I'll have my state duplicated in two places, and that's a bad thing. So yeah, it's an abstraction. It takes away complexity and gives you a more simple API to program against, where you don't have to think about those problems. So yeah, I think it is just a higher level of programming, I suppose, where you don't worry about many of the mundane pieces of where your code runs. You just write your code and it goes and runs on this somewhere across this cluster of machines. You don't even know where. In fact, the ideal placement strategy is random, where it just randomly picks a machine and puts your code on there.
What has changed in the last 10 or 20 years that made what was a hard problem now as you said, a mundane problem? Because what I'm hearing you say is that these were hard problems and now they are solved. So why do we as application developers have to worry about them anymore? Like, it should just be a solved computer science problem. Have the PhDs write a framework and we talk to that framework and problem solved.
I think it's hard. What's changed in the environment is that we now have cloud computing. So we have these enormous compute infrastructures where we can deploy our software, and you will have failure all the time because you're running on thousands of nodes and these things fall over. And you're also seeing requirements from customers where they want to do more and more stuff. They've got IoT kind of scenarios where you've got millions of sensors and you want to get all this information into a system and then reason about it. And you can't use traditional programming techniques in those scenarios. You can't just put it all in a SQL database and push all your locking and thread safety stuff into some other system. You've got to either come up with a radical new architecture like CQRS and event sourcing and have eventual consistency, or you have to go down a stateful route, which is one that the actor model supplies. So these aren't solved problems. There are a bunch of good solutions out there, of which Erlang is one and has been using some of these techniques for a long time. But innovation continues to happen, and they've got some really fantastic people still in Microsoft research, still contributing to Orleans. So Phil Bernstein, the pioneer of ACID transactions and databases, is running a small team which are looking at doing transactions across an Orleans cluster. So there's still research work and interesting stuff going on, and as a community in Orleans, we're looking out at what's happening in the world of research and industry, and trying to pick out interesting technologies and thinking about how we can pull them into Orleans and learn from them and implement them. So looking at things like the Bond serializer, looking at the Raft protocol and how we implement that in an application on Orleans, and so on and so forth. So I don't think everything's solved, but I think we're on a interesting trajectory of trying to solve these things because of these problems.
Could you mentioned CQRS, command query responsibility segregation, an extension of the CQS principle. Could you briefly explain where that splits off and it goes in one direction and the actor model goes in another, or how are those related and the same or not the same at all? Yeah,
they're different approaches, I think, to solving high scalability problems. So CQRS which goes hand in hand with event sourcing, says you need to separate your read and your write concerns into different channels. And when you do that, you introduce eventual consistency, so you don't expect to see your writes immediately in your read channel. But that then enables you to get over some of the scalability limitations of traditional databases. You can now kind of store your data in several different places and shard it and push it across to the other side of the world. Mm-hmm. And that's okay because you've got this eventual consistency and this latency, and you kind of give those cards away. In the world of distributed systems, you can't have it all. You've got to decide what are you going to give away,
right?
What trade-offs you're going to make. So there are different approaches that make different trade-offs, and it just depends on what your requirements are. What trade-off is the best?
Many years ago, I want to say 2004, 2005, I was working in banking, and certainly I wasn't sophisticated enough to come up with a name like CQRS or have conversations with Martin Fowler about it. But we basically had the same idea that, well, if you're at a giant distributed system, which we had built in DCOM, you can either get it, they say good, fast, or cheap, right? Pick two. Mm-hmm. You can get it fast, or you can get it consistent, meaning I do a write and then I do an immediate read and I get guaranteed that it's going to reflect the reality. Or maybe you just can't have a really real-time system. Like, how real is real time? Are you saying that with these virtual models that it will eventually all work itself out, as you say, eventual consistency, but you can't have it perfectly to the millisecond up to date and also fast and also scalable all at the same time?
I think you get some of that with Orleans. The normal kind of trade-offs you make in distributed systems is around the cap theorem, right? So you can have, you're going to have partition tolerance because that's going to happen and your app has to deal with it. So it's really then, does the app steer to the consistency side or the availability side? And so in the event of a network partition, when nodes are split and they can't speak to each other, what do you want your application to do? Do you want it to be available, or do you want it to be consistent and therefore not available or partially available? And there's all kinds of nuances in between where you can have different levels of guarantees, but that's broadly the trade-off.
So just to give... Sorry, I just want to make sure we give context for some people who may not know some of these acronyms. Mm-hmm. So I use the common computer science joke, good, fast, or cheap, pick two. The CAP theorem, CAP, was called, is Eric Brewer's theorem that says something, a computer science that a distributed system can't be consistent, where everyone has the same data all the time, available, where every request gets a response and says, yes, it worked, it didn't work, or have partition tolerance, where it's going to continue to work during network failures. So consistency, availability, and partition tolerance, hence CAP.
That's the one.
Are you saying that have we proven this wrong, or is that still an issue?
No, Orleans strictly keeps to CAP theorem and is on the availability side.
I see. So that is the most important of the three from its perspective.
From its perspective, yes, to maintain availability. So in the situation of a partition in the network, you may well get two activations of your actor. We call them grains in Orleans. But there's things you can do to compensate for that. There's some active research going on into how to reconcile these kinds of things. Or you can defer to a consistent store like the storage systems in Azure to say, I need to be very certain that I'm the only activation, and then you can make your grain more C than A. Mm-hmm. So you can make those trade-offs at an application level as well. But yeah.
So that's really interesting, I think. Like, it's one thing to say our framework values C, A, or P in a weighted way, but to allow the programmer to decide as they want, as the situation applies, what is most important to them is interesting.
That's right, yeah.
So this started off as a Microsoft research project, but this isn't a toy. They use this for Halo. They
did, yeah. 343 Industries kind of approached MSR and said, we're bringing out this game in 3 months, and we really need a system to support the back-end services. And
they said, 3 months?
Yeah, we got this thing called Orleans, and they got it done.
We got this thing called Halo, and it'll be fine.
Yeah. I think it was one of the other games, not Halo 4. There was a game before then, I forget the name. But then it proved it with that game that it could do the job. So when Halo 4 came around, they pretty much built all the back-end services with Orleans. And so whenever you take a headshot or something, it all goes through the Orleans cluster, and it supports the kind of second screen gaming and the portal where you can see your stats and all that stuff.
So this has been proven. This is something that we shouldn't worry about. We shouldn't say, oh, no one's using this, or no, this can't be successful. This is and has been successful.
Yeah, it's used on several kind of internal Microsoft projects as well. So it's not just the games it supports, like the Halos. It's the Skype calls are rendezvoused in Orleans, and the Windows Phone, if you remember those, they make use of Orleans as well, and bits of Azure. So it's used all over the place. And there's of course lots of external customers. People like Visa are using Orleans, and some other projects I probably can't mention.
This episode of Hansel Minutes is brought to you by Braintree Payments. Why make payment integration more difficult than it has to be? Braintree's powerful full-stack payment platform allows you to accept nearly any type of payment from any device with one integration. It's flexible to your system's needs, supports most programming languages, so whether you're using Java, Ruby, or Python, you'll always have a range of server-side and client-side SDKs available. Braintree makes payments and your job a whole lot easier. You can learn more at braintreepayments.com/Hanselman. That's braintreepayments.com/Hanselman. So why wouldn't we use this for everything? Like, this might be a dumb question, but you've got perpetual existence where the actors are just out there and you just ask for them and they're cool. They're always addressable. They're always, they get instantiated automatically. You get location transparency, which is what they always promised us in DCOM for 40 years. They've been promising us location transparency, and this now is real. And then the holy grail, automatic scale out. This means that, doesn't this mean we should write every application this way forever?
Good question. So,
thank you.
I think Orleans has its strengths, but it's not perfect for everything. You should pick the right technology for your set of problems. And it's sometimes hard to model your scenario with the constraints that Orleans gives you. So sometimes you want to do things like aggregate queries. You want to say, give me the top 5 best scores in the game, or something like that, or how many players have I got at the moment? Oh, they're the kind of aggregate queries that you can run very easily in a database. Select count star, but they don't work very well in Orleans because you don't know what's activated or not. You just got a bunch of objects pooled in memory, and so to answer those aggregate queries, you've got to go and do a bit more work. So those kind of things don't fit so well.
And then they're distributed, right? So if you decided to go and model, a universe or Halo, and you could certainly have you and I shooting at each other, and presumably the Orleans system is going to figure out the best way for us to be able to do that, and maybe we'll end up on the same machine. But then I want to suddenly say, for each player, I'm going to for each over 40 million players on X number of machines. This is not that. This is not a SQL database.
Correct. Yeah, you're not going to don't write a query that goes and talks to every single actor in your system. No, that's not going to scale.
Okay. Well, what about persistence then? What's in the back end? Is it magical persistence, or is it like a giant distributed hash table?
It's swappable. So by default, you can have either Azure's table storage, or you can have blob storage, which was contributed by the community. Or you can have SQL, or you can go and plug in your own thing. So people have written providers for Redis and for other database systems, RavenDB, and you can go and plug it into that. So you could, in theory, just go and connect to any data store there's this kind of automatic persistence layer where it just persists the grain state for you, but you can always go and just load your own state by yourself. So you could take a existing traditional database that's been the property of your company for years and just stick Orleans on the top of that.
And is this is a .NET thing only, right? So this runs in .NET full framework?
Yeah, it's .NET 4.6.1 at the moment. Is that right?
4.6.1? And this is it only a Microsoft thing now? Because I understand that one of the original people on the Microsoft research team, Gabriel Cleot, now works at Google. So this has kind of become a cross-company project.
That's right. So yeah, it is full .NET, but we are actively working on porting it to .NET Core. Mm-hmm. So that'll give us the cross-platform capability that people are asking for, which is really good. Mm-hmm. And yeah, there's a core team. There's a team of Microsoft employees, about 5 or 6 of them who are paid full-time to work on this in Microsoft Studios. There's a kind of extended team in Microsoft Research still who are contributing. And then there's people in the core team who are not Microsoft employees. So people have come from the community and been given commit rights to the repository. So Gabriel, he left for Google, but he's still merging pull requests and commenting on all the threads. And we've got people who've been recognized for being really good contributors and made outstanding contributions, and they've been given the keys to accept pull requests as well. So that's fantastic. Could you imagine saying this a few years ago, that you've given people in the community access to maintain Microsoft's property? It's a fantastic situation to be in, isn't it? Where you have enough trust in people, random people on the internet you've never met, to have permission to do anything they want with your products.
So how does the sounds like the community is quite healthy. How do you make such a successful and healthy community around something that is so for lack of a better word, PhD feeling? Yeah,
it is surprising how good the community is, and I think there's lots of reasons why it's been successful, but I think the main reason is the human factors. So I think with large open source projects like Node.js, you have a committee of people who maintain and steer the project. But in smaller projects like this, I don't think that's so appropriate. And what we have is a leader. The main dev lead who's been running the project since it was started is Sergey Bykov, and he's fantastic. He's the best leader you could have. He's humble and approachable and inclusive and encouraging, and he reaches out to people in the community and talks to them about what they're trying to do with Orleans and points them in the right direction and everything else. So I don't think we could have a better guy behind the wheel, really.
So strong leadership at the top is what you're saying the best way is? And then do you then set the attitude going down as far as like how we're going to treat pull requests and how we're going to treat our architecture and all that kind of stuff? I definitely think, that good community starts with good, strong leadership and setting the right culture, and then the rest will follow. And he goes out of his way to try and encourage the community and set a direction. So, for example, we have a clear roadmap of things we're trying to achieve in the product, in the project. And that's something he went out to the community to go and gather and put together and then presented back to get feedback. So he's engaging people and working with people in the community to build a roadmap that fits what's best for Orleans, not what's best particularly for any of his internal customers. And then that gives people a focus, something to work against, some big things in that roadmap to try and do, like the port to .NET Core. And when you do that, it gives this kind of guidance to say, this is what we're trying to achieve, and if you want to go and contribute a big feature, then have a look at these things that are on the roadmap and put your energy into these things, rather than people taking you off in odd tangents and directions of places that you don't want your software to go. And is a lot of this done in chat or virtual hangouts, or how do you collect this? Because everyone's so distributed now. Yeah, that's right. Well, we've got lots of channels. So we kind of do a
a virtual meetup, which we stole from you, where it's a bit like your ASP.NET Hangouts, but we have a couple of presentations. People talk about some feature they're working on in Orleans, or some ideas they have, or how they use it, for example, with a presentation. And then we have some questions afterwards. So it's much more of a kind of meetup concept. We try and get as many presenters in as possible and have a conversation and a dialogue. So that's one means, which I think is really important for the kind of deep techie stuff. We also have a Gitter channel, which is the kind of new IRC, I suppose. And that allows us to have the kind of water cooler moments, I think, where you all kind of hang out together and chat about an issue, probably in more detail than you would want to put in the issues list. Or just shoot the breeze and talk about random stuff that's not related to Orleans. And then we have the GitHub issues, which I suppose is the real engine of the decision-making and the fostering of ideas, and, of course, the pull requests in there and the code reviews. So I think there's no one way of running it. All these things work together, but they're all very useful. I think probably the most useful, most surprising to me was the Gitter channel, because that's really used just as much as a kind of support mechanism as it is for us to get together. You know, people pop in there, they ask a question. Often the questions are quite open-ended and not the kind of questions you can really ask on Stack Overflow. They're, I've got this problem. Is this a kind of Orleans problem? And we can ask further questions and kind of try and figure out what he's trying to do. And people find that really, really helpful, I think, being able to have a dialogue rather than a kind of short answer on a Stack Overflow answer. So,
do you think it'll scale, though? I mean, at some point, don't you think at some point a framework will become so popular or so, so used that kind of high touch can't scale?
It's an interesting question, isn't it? I think, I hope that when the popularity grows and you get more users, at the same time your community grows as well, and then you've got a bigger kind of contact area to touch with. We don't know until we scale it. I mean, it's not something we're worrying too much about at the moment, but it'd be a nice problem to have. So we'll wait and see.
So how hard is this to get started? What's the hello world scenario? Because, when we think about these new frameworks that are opinionated, that declare, you should do your things like this, sometimes it can be a little overwhelming to set up and get started.
Yeah, trying to reduce friction, both for developers and for users of Orleans, has been really quite important. And so we've tried to make it as easy as possible to get started by providing documentation and samples and everything else. But you can literally NuGet install a couple of packages, and you create an interface, you create a concrete class, you download a kind of runtime, or you host the Orleans runtime yourself, and you're going. So it's not that tricky. It's quite straightforward. Lots of people manage to get a hello world to work. So I encourage you to have it. Have you had a go, Scott?
I have not had a go, but apparently I have to now because it's easy.
It is easy, yeah. It's too easy.
Now, are there other frameworks though? Like, is Orleans the only way to do the actor model? And I know that there's Akka.NET. I know that there's Service Fabric. I'm sure there's probably others. How do I pick one? Yeah,
it's funny. 5 years ago, there were kind of no actor models on .NET to choose from, and now there are 3. And you're right there. Service Fabric has a actor model over the top of it. Akka.NET, which is a port of the Java Akka project, and of course Orleans now. So choice is good, and we actively try and reach out to those people as well, and see how we can work together. They're all slightly different. They make different trade-offs. So I wouldn't say they're all direct competitors. They're in kind of slightly different markets. It's really interesting to see that a chap called Yevhen Brobov has built an API over the top of Orleans to make it look more like Akka. He calls that Orlean Anchor. And you can go and download that, and an Akka user will probably feel more comfortable using Orleans that way. And it's got fantastic F# support. And another guy, Ruben Bond, has got Orleans running on top of Service Fabric. So you can kind of get the best of both worlds. You get the cluster membership and the data locality of Service Fabric, but I'd say slightly better actor model that Orleans provides. Certainly has more features.
So how do you run an actor model on top of an actor model, and is that a good thing?
Well, Ruben's developed this project he's open sourced, which kind of bootstraps Orleans on top of Service Fabric. I think it bypasses Service Fabric's actors and goes straight into their services, because it's a kind of multi-tiered system, isn't it, Service Fabric, where you can pick your level of abstraction. So he's gone down deeper. And we're currently working on ways to make Orleans plug better into Service Fabric, which we'll slowly get through, hopefully.
So then that means you do get the best of all the different things that are available to you. There's value on all these sides, and when you add them up, you do get something that is better than the sum of its parts. I
think so. I think the Service Fabric and Orleans combination could be really strong. I think there's a bit of complexity because you're introducing more moving parts, but it might be the way to go in the future. Yeah, it'd be really nice to see the Service Fabric team kind of cooperate and kind of embrace Orleans a bit more. But we'll see. Maybe one day they'll open source that as well.
Well, it sounds like with all of these things, if they're open source and if they run hopefully cross-platform and they have enthusiastic communities, while there is, competition, there can also be co-opetition.
Yeah, I certainly don't see these other projects as a threat. I think it's definitely good to have. Kind of a friendly rivalry to see. It's not about which is the best or anything, is it? It's just about how can we all serve the .NET community, really? These are all, Akka.NET and Orleans are open source, so it's not like we're making any money out of it. It's just giving .NET guys more choice, isn't it, and more freedom. Very cool. Yeah.
So folks can learn about Orleans at .net.github.io/Orleans, Orleans. And it's got a very, very approachable website. The code is on GitHub. There's both stable and unstable releases that you can get. It's regularly being worked on, and it has really lovely and complete documentation as well. It is a very well-run project, and as you may have seen during the .NET Conf kind of opening State of the Union address I did, it shows up as one of the most active projects within the entire .NET open source community.
That's right. Yep.
This has been great. I really appreciate you taking the time to break it all down for us today.
Thank you for having me. It's good. I can't really stress enough how important it is to have a good community around these kind of projects. When I kind of got on the show and you invited me on, and I went onto our Gitter channel and said, has anyone got any ideas of what I can talk about? And one guy, the overwhelming response was, we came to Orleans because of the community, because we tried a few other places and they weren't very friendly, or they didn't really want the contribution, or they didn't answer our questions, and so we bounced around a bit and we ended up on Orleans, and it has been great, and we're going to stay here and we're going to become contributors, and we're going to really help you build this thing, and we're going to talk about it and contribute features. So I think in several cases the strength of the community has won us more business, if you like, for an open source project. So more users is better, isn't it?
Well, hopefully people will look at it and watch how you all react to pull requests and issues and see what a healthy community looks like, and try to mirror and emulate that.
Super.
Thanks so much, Richard Astbury, for chatting with me today. This has been another episode of Hansel Minutes, and we'll see you again next week.